All right. So this is the topology and this is the output from our previous class. Now, can you tell me what label the router is using, before sending to router 4? Router 5, from router 5, we are tracing the route to reach 1, isn't it? Our destination is 1.1.1.1. And we are going from source 5.5.5.5. So the packet is going from this router. From this router, it is going. Now, what label router 5 is using to talk to router 4? See, for router 4, router 5, which is the first hop? This is the address, right? This is the address. Now, you see, the label it is using is what? Now, tell me, the label 400 is given to whom? Exactly. We gave here range between 400 to 499. And here, 300 to 399. Likewise, 200 to 299, 100 to 199. You remember that, right? On router 5 also we gave 500 to 599. I told you, when we enable MPLS, every router will generate labels. Now, why router 5 using router 4 label? Router 5 is sending the packet to router 4, isn't it? Why it is using 400? That's not the label of router 5, no? Router 5 is sending the packet, but router 5 is using the label given by router 4. How router 4 gave this label? Using which protocol? Exactly. Using LDP, it has given this label. That is how router 5 knows. I'm answering now the question. Router 5 is using label 400 given by router 4 for the network 1.1.1.1. 5 is using label number 400 given by router 4 for which network? For which destination? Exactly. Only then router 4 will know that this packet is for 1.1.1.1, isn't it? Router 5 should put 400 and send only then 400 is the label. So if router 5 says 400 in the header, in the MPLS header, router 4 will understand that the packet needs to go to 1.1.1.1. Likewise, router 4 is putting label number 300, which is given by router 3. So when it goes with 300 label, router 3 will understand that the packet is for whom? Exactly. Now, this is a very important understanding we should have towards the labels in MPLS. Very important understanding one should have about the labels. Router 5 will not use its own label. Router 5 should use the label given by the downstream router. Who is downstream for router 5 towards 1.1.1.1? Who is down? Router 4. For router 4, who is downstream? Exactly. So We have to understand this very well. Every router will use the label given by the downstream router. You please understand this. This router 4 would have given, sorry, router 4 will have 1.1.1.1. Label given by router 5 is 500. Label given by router 3 is 300. Yes, it will have both the labels. But which label it should use? It should use the downstream label for 1.1.1.1 because this is the direction of 1.1.1.1. You understand, sir? Now, when you have time, you said you have done the lab. I want you to on the lab later and then type this command: show MPLS LDP binding. You type this command, then you will see these three things. What are the three things? You will have local label. 1 minute. You see, this router 4 will maintain a table. And the table will have local label and also the label given by the adjacent routers. So for better clarity, what I'm going to do is, I'm going to write here the binding table. For 1.1.1.1, local label is 400. Local label given by router 5 is, actually here router 5's address will come. Okay. Router 5 given label is 500. Router 3 given label is 300. This is what we call it as binding table. It will have all the label, not only the downstream label, not only the label given by router 3, it will also give the label, it will also have the label given by router 5 for 1.1.1.1. So tell me which label it should use if it wants to go to 1.1.1.1, the downstream, which is 300, not 500. It will never use 500. Why? According to the routing table, the exit interface is Ethernet 00. According to the CEF table, Ethernet 00. That is the exit interface for this. So it will never use this one. Even though it is having it, it won't use it. Then why it is there? Why it is there? It is there because in case if you have another path and if something goes wrong with this path, immediately it will swap to 500 and send this way. You understand? It's high availability. Okay. High availability, yes. You see, the labels need to get distributed. Otherwise, MPLS cannot forward the packet. They have to know what number, the label number, my neighbor uses. Only then I can go tell that code word, hey, 300. Immediately router 3 understands that the packet is for 1.1.1.1. So it no need to do a layer 3 header lookup for the incoming packets, because every incoming packets is giving the keyword. You know, it is giving the reference number. So easily, you know, you can, you know, for example, when you take a flight, if you will have any one of this, like PRN number or booking registration number of the ticket, they will easily get you a boarding pass. You no need to say my name is Jayachandran, the last name is Satyan, and I'm going from this to this country on this date, and you no need to say all this. Just give them one reference number of the booking. They will likewise. Just give 300, router 3 will understand the destination. So labels need to be distributed. Fine. That is one thing. Secondly, what I want to say is when you are tracing the route from 1.1.1.1 to 5.5.5.5, router 5 is actually what it is doing. It is pushing one label inside the header, which we called as push operation. Push. Push or a label impose. Impose is also another word. Some people will use label impose. Some people will use label push. And now what happens when the packet goes here with the label number 400, router 4 is swapping what? Swapping with which label? Router 4, after receiving the packet, it understands that exactly. So that is what called a swap operation. So it removes that, it swaps with the with 400. The 300 is swapped with 400 is swapped with 300. Now the packet goes here. This also will have a downstream label. What is it? 200. So again here also swap operation will happen. And the packet will go here. This will see label 200. And what it will do, it will not swap with 100. It won't swap with 100. You see? While sending to router 1, there is no label. 400 was swapped with 300. 300 was swapped with 200. But router 2, when it sends to router 1, no swapping. No swapping. Why? It is because router 1 did not distribute label 100. It won't distribute. Instead, it will distribute a special label which is 3. Yes, 3. This label number 3 means router 2 will learn what? A label number 3. For all the connected networks of router 1, I repeat, every router, for all the connected networks, it will advertise same label, and that label will be 3. 3 is the only label for all connected network. For example, router 2 will advertise label 3 for 10.12 network to router 3. Yes or no? Router 2 will advertise label number 3 for 10.12 network. And router 2 will advertise label number 3 for 10.23 towards router 1. Do you agree? Label number 3 will be given for 2.2.2.2 network, both for router 1 and router 2. Both router 1 and router 3 will receive label number 3 for 2.2.2.2 from router 2. Do you agree? Yes. Now, whenever a router receives label number 3, it will immediately write in the binding table. I asked you to check the binding table. Later you check. Show MPLS binding table. Show MPLS LDP binding. LDP. Show MPLS LDP binding. When you use this command, you will see on router 2 it will be like this. On router 2, 1.1.1.1, local label is 200. Label given by router 1 is POP. POP means label 3. Label 3. And label, this is on router 2 I am writing, okay? Router 2 binding table. And the label given by router 3 is 300. And which is the downstream? Router 1 is downstream. So when a packet is about to go to the downstream, because it is written here pop label, it will pop. You can also with label 3, that makes router 2 to understand I have to pop, so it will write pop label. It won't say label 3. In the output, you will not see label 3. You will see only pop label. But internally, that is what happens. If you capture the packet with the Wireshark, you will see label 3. Put label. It will push simple IP packet without MPLS header. So why it is doing like that is what next question we should ask and we should understand. Why is it not using the label while sending to the last router? Why is it not using the label while sending to the last router? I'll tell you the answer. Let us say it is sending one label 100, assume. It is sending with label 100, assume. There is no pop label concept. Assume that there is no pop label concept. It is putting label 100 and it is sending to router 1. What router 1 will do? It will receive with label 100, fine. It understands that the destination is 1.1.1.1, but where is 1.1.1? It is connected on the router. So it has to go through the entire layer 3 header in order to push the packet on that port. Just knowing the interface name is not enough to deliver the packet. It needs to know the checksum value. It needs to know the sequence number. It needs to know a lot of things to deliver the packet to the final destination. It is not just a transit router. Is it a transit router? Is R1 a transit? No, that's a final router. So the final router needs more information than the destination IP. It knows the destination IP, but from where it will know the sequence number, from where it will know the other things that you have in the IP header. You have to go to the IP header. So it will go again to IP header and get those information to deliver the packet to the loopback. To avoid these two unnecessary lookups, to make it as one lookup, to avoid this, what lookup? To avoid this, on the packet, incoming packet, destination route, yes, in R1, to avoid two lookups, MPLS lookup and then IP header lookup, to avoid the two lookup, make it as one lookup, router 2 while sending itself, it will send without the MPLS header. You understand that, sir? No. That's what I was telling you. See, to deliver a packet to an interface, which is directly connected, physically connected, or logically, whatever, on the router, just the IP address alone is not enough. The receiving router, when it receives the packet, if it receives the label, that label will only show the exit interface. But this is not only the exit interface, this is the final destination. So the destination needs to know whether this is the last packet that I am receiving whether it is a first packet I am receiving, it has to rearrange. The TCP header, a lot of things are there. It has to check the length of the packet, that header length, all those things. Is there any QoS needed? After checking all this, only it can deliver the packet to that connected interface. So if you will send with the label, it needs to again look into the IP header, which will be double work. So before sending to the final router, we don't send the label. We just pop the label and send it to the final destination. Now, yes, the final destination router will now look into only the routing table and the layer 3 header in the packet and delivers the packet. We call this process of removing the label before the final destination. We call the process of removing the MPLS header before the final destination. When you pop the label, we call it as PHP. Popping before final destination. We call it as PHP. Pen ultimate. Exactly. Pen ultimate hop. Hopping. Pen ultimate hop popping. PHP. Okay, now you tell me, if I will ping from router 5 to 2.2.2.2, where will be the PHP happening? From router 5, no, please understand. I want to ping 2.2.2.2 from router 5. Exactly. 3 will pop the label. 3 will pop the label. PHP will happen on router 3. Now, this is what you need to check in your lab. You have said you have done the lab. So you can see this pop label thing in two different places. One, usual command that you use to type show MPLS forwarding table. Okay. There also you will see for some that the outbound label is pop label. The other command I showed you today is show MPLS LDP binding. I want you to check these two things and come. Tomorrow something very serious is starting in MPLS. Very serious.